Hello everyone, welcome back to the first video in this brand new series, and this will be a C tutorial. Eventually it will become a C++ tutorial once we are done with this, but I'll be posting a couple of videos going through the basics of C, and actually it will be kind of interesting because I'm actually learning along while I'm making these videos. I have a little bit of experience with C and C++, but I just thought to myself, what better way to learn it than to try and understand it enough that I'm able to explain it to others. Now, I will be making a lot of references to Python because that is a more commonly known language. It is pretty easy to pick up even for those who haven't programmed before. And so it is useful to be able to make references and make comparisons for you to be able to understand it. Now, first off, we're going to begin with um, understanding what is C. C is it's a programming language and it's considered a high level programming language. Now, what does that mean? High level just means that we are speaking in the language of humans. When you read C code, even though you might not know the syntax, you might be able to understand what it's saying. If a computer was to read it, however, it wouldn't be able to understand it because a computer understands zeros and ones. It understands binary. So this is considered a high level language. Now, people do think that this might be a low level language because they compare it to Python, but they're both actually high level languages. Now, if they were to be like ranked, then yes, Python would be higher level. This is closer to machine language than Python is, but they both are considered high level. Now, how is this different from Python? Now, this is considered to be a compiled language, and this means that we use some sort of compiler to turn our code into machine language. Now, what is Python? Python is actually an interpreted language. If you remember, we didn't need to use any any compiler or anything to turn the code into machine language. We just click the run button, and that's because in the background there's the Python executable program, and that actually reads your code and then executes what it's trying to say. Now, this is different because C and C++, how it works is we write our code and we actually can't run that because the computer doesn't understand it. We have to turn it into machine code by making an executable file, and then the machine understands it. Now, I will be using Ubuntu here. I'll be using a bash just to manage files and stuff like that. You don't necessarily need to understand what's happening in this terminal. I do recommend that you learn it. It is pretty important and it goes hand in hand with anything that you do when you program. But first, let's just make a write code directory. And here we're just gonna keep everything. Now let's make a let's call it tutorial, and now we're gonna use a .c. That's just the extension type for C files. And if you go into here, if you write code dot, well, there you go. It opens up VS Code. I'll be using this as my IDE, and the only things that you need to get set up in the background is you do need to figure out how to install a compiler. I will be using GCC. It is pretty easy. You can find other tutorials. And for extensions, I believe you just need the C, C++. Okay. Oh, well, it's not supposed to have main here. I was testing something earlier. We're going to be using tutorial. Okay, now what else do we need to know about C that is different from Python? Let's actually make a tutorial.py file so I can compare it. Now, if you remember in Python, we can just create variables. X is equal to 4. This makes sense. And we do that by using the assignment operator, and this creates a new variable called x, and it has the value 4. Now in C, what do you think x equals 4 does? This actually doesn't work. It spits out an error, and that's because it is a statically typed language. That means we have to predefine data types before we use them. Now what does that really mean? That means that we have to tell the machine what type of data to expect. Okay, so here we're using int. Int is just an integer. It can store numbers like 1, 2, 3, 4, 5, 6, and so on. And after we define it, we use a semicolon to end the line. Because if you remember in Python, well, actually, if we just start a new line, that we move on to the next thing to execute. But in C, we don't move on until we see the semicolon. These spaces don't mean anything, so we can actually keep throwing a bunch of stuff, and as long as they have semicolons in between, well, the machine reads it fine. Now, this intx, obviously, after it's already defined, then we can go x is equal to 4. And, you know, it might be pretty obvious, but if we were to do x equals 4 beforehand, well, this would spit out an error because, again, the machine doesn't know what type that x will be. Now, just to compress this, we can also define it within the same line, like this. So, it's not too bad. Now, another thing that we need to keep in mind is because we are predefining this integer type, we also can't change it. Remember, in here in Python, we could just go x is equal to anything. We can throw some random string if we want to. Here, if we were to use a float, because actually strings don't exist in C, we'll talk about that later. If we were to throw a float, which is just a floating decimal, this would actually spit out an error because here the machine reads this and it sees x, and you see that you're trying to change it to 3.99, but x is supposed to be an integer. That can't happen. And that's basically what statically typed means. Now, let's start off by talking about how a program actually works. A C program works by running the executable file, and your operating system starts your program through what is called an entry point. Now, what is an entry point? An entry point is basically, it's the first function that is called to start the program. Now, in Python, when we run this, the machine just reads it from bottom down, right? That makes sense. Now here, what's different is in C, we always have a int main function, and this int main is our entry point, meaning that whenever we call the executable file, this is always the very first thing that we call. And you might look at the syntax of this and see that it is very different from Python. We have int here for some reason. We have the function name, obviously, parentheses, and we have open curly brackets instead of, well, we don't use indentation to nest functions and statements. We actually use these brackets, and everything inside here is the body. Now, let's look back to this int. Remember, we said that C is a statically typed language, meaning that data types need to be predefined. Now, it's not just data types, it's not just variables, it's also functions. Now, you might ask, how does a function have a data type? Well, this int actually defines the return type. And by default, our main is always int in C. It is different in C++, but in C, we always define it as an integer because, well, we need to return something. Now, this looks very similar to Python. It is the exact same, just we need to add a semicolon. We have to return something. Now, we usually include this at the end, and by convention, we do return 0 for most C programs. Now, you might be asking, well, if the operating system is calling this, then, well, who gets the 0 back? We're not actually calling this function from a different function, and that's exactly who gets it back. It's the It's the operating system. If we were here, now let's look at how to run these files, and I'll show you what I'm trying to explain. Now, remember, well, if we look at what files we have tutorial.c. We can't just call the file tutorial.c. We get a permission denied. Now, even if I were to switch the permission, that doesn't change anything because the machine simply can't read that type of information. Instead, we have to use our GCC compiler, and we give the name as a argument. Now, nothing happened, but if we check ls, we have this new a.out file, and if we were to call it, well, nothing happens because nothing happens in our program, but that's actually running the program. And what we could do instead, well, let's say you want to change things up. Let's first remove this a.out. Well, what if we want to give it our own name? You will be naming your own executable files a lot of the time. What we could do is, again, pass the argument and put -o, and here we could give it any name. And let's just name it as anything we want, tutorial. And let's get rid of the Python tutorial.py because we have too many tutorials. Now if we check here, we have this tutorial and we have this tutorial.c, and if we were to run tutorial, well, nothing happens. But remember, we have the this return 0, and it's coming back to the OS, the operating system. Now, how do we know that that's actually happening? Well, if we were to use the command echo and this $sign and a question mark, we can actually see the return type from from any function that we've called or any program that we've called, and we get a 0. Now, let's say we go here and we switch it to a 4. This return type can be anything, and let's say we call it again and then call echo again. Notice we'll get 0. And that's because I want to highlight something important. This isn't Python. We can't just run and expect the changes in our program to be applied. We have to recompile every single time because, well, remember, it's the executable code that we are actually running. It's not the file itself. So we have to go gcc tutorial.c and give it the name. And be careful with what you name it because the compiler will overwrite whatever file if it already exists. Check. Yep, we made it. So now we go tutorial. And now if we check what our return type was, 4. Well, it gave us command not found because we didn't use echo, but that's not important. This 4 is what's important. Now, you might be asking yourself what this 4 is used. Well, these are just return statuses. They're exit statuses, and that just it's just a way for you to be able to tell the operating system if something went wrong. Different codes might mean different things, and that's for you as the programmer to define. Now, moving on, we'll step away from this int main for a second, and we're gonna actually use a statement that might look a little bit weird, and it's a hashtag include std for standard, and then io for input output, and .h for header. And this might look very weird, and this just means that this is what's called a preprocessor directive. And for now, you can just think of it like an import statement library. We're just importing a library. Get rid of this. Now, this library actually gives us access to a function called printf, and might be self-explanatory, but this allows us to print stuff. So now we can actually do things. This IO, obviously, input output. Print is an output function. Now, this print function works a little bit differently, but we will talk about that in a second. First of all, let's finish up talking about this function here. We didn't talk about these parameters. How do parameters in Python work? Well, we just throw function names or variable names like x and y. But what actually happens here in C is that we actually have to predefine their data type because it's a statically typed language. That's all it is. For now, we won't use any parameters because we are writing a very simple function. But from there, what we can actually do is look at this print function. And just to see that it's working, let's print hello world. Very simple. And we'll use a \n, which in most languages means new line. Now let's see if that worked. Remember, we have to recompile. Oops, we made a mistake. We check, and we forgot a semicolon. That's one of the things that the compiler does. Now we call it hello world. Okay, pretty simple. Now, let's say we want to print a variable. Int x is equal to 10. Well, also pretty simple. Well, let's see what this gives us actually. It gives us an error. And that's because this works differently than Python. We can't just print variables. We can use something, these identifiers. Now, what does that mean? They are, in Python we have something called f-strings, and that was a way to format our strings to include variables. But in here, how it works is we have this variable, and instead of having an f and including something inside, what we do is actually, well, we have whatever we want in here. Let's say we want our number is, and wherever we want our integer to be, we throw this decimal identifier in. This %d just tells the program that, oh, the next argument, which is a integer value, this stands for decimal integer. The next argument, which is a integer, well, replace this %d with it. And now if we were to recompile, let's just clear all of this, we shouldn't get an error this time. And if we call .tutorial, our number is 10. Okay, perfect. Now, what about other data types? Well, first let's go over just two more data types that are very common that we will talk about for now. Our character. Now, this is some letter, and remember in C, actually, we don't have any strings. We can't just store a word hello world, and I believe this would throw a error at us. Yes, because it's not it's not an existing data type. What character does is, well, we use single quotes, and it stores, well, a character. Whoops. One single letter, A. And the identifier for it is actually C for character. Now, if you replace it here, we recompile. Our number is A. Now, notice how this gets ran right over it. It's because we deleted the \n. And it's not like Python. Python by default has a \n to end your print statements. Okay, now one more thing to think about, to know for these for this character data type is actually we can use a what's called an ASCII table to define our characters, but we can actually use numbers, and this ASCII table is just a way for us to code in certain characters with numbers. And if you look at it, we can use the number 66, for example. And if you look it up on the ASCII table, that corresponds to a capital B. Now, you might think that this will throw an error because this is an integer, but no, it'll just read whatever corresponding ASCII character is. And if we call it, we get our number is B. Okay, now let's talk about one very last character type, which we talked about before, the decimal point, and this is simply called a float. And you could throw in decimals, and the identifier for that finally is actually, well, percent %f for float. Throw a float in here. Oh, whoops, we called it decimal. And if we recompile, and we forgot the semicolon again, that's usually the most common error, we get this. Now, there are rounding errors, which is why you see the extra zeros, but you can ignore that for now. Now, there is one more thing, and we will talk about this in the next video, but let's just, since we're talking about identifiers right now, this %s is actually for string literals. Now, notice how we use double quotation marks for it, and that's because that defines a string literal. Now here we could say hello world. We could say our phrase is. Now see, even though this isn't a valid data type, we can still store it. Okay, now if we were to compile and run our code, we get our phrase is hello world. And that's pretty much it for today. So far, you should know how the very basics of how C works, how to define integers, how to print a string literal, how to include different data types inside of your string and how to print them themselves. Well, now we know what an int main is and how it is essential to every single program, and how it requires a return. We also went very briefly over this include, and we'll dive deeper into all of this in the next video. Thank you guys for watching, and I'll see you guys in another video.